Hello everyone, my name is Abhishek and welcome back to my channel. So today we are at day 31 of our free DevOps course, and in this video I'll be talking about the Kubernetes architecture. So before we jump onto the topic for today, let me start with a very lighter note question. Why Kubernetes is called as K8s? So everybody knows that Kubernetes in short is called as K8s, but to just start with a very fun question, let's see how many people can answer this question. Why Kubernetes is actually called as K8s? So this is not at all an interview question. So I'm just trying to start with a very simple question because we are going to deal with a very complicated concept. Okay, so let's try to understand the architecture of Kubernetes. But before that, if you know the answer, definitely put that in the comment section. So coming to the architecture of Kubernetes, firstly, you should understand the difference between Docker and Kubernetes. So that is the same thing that we try to understand on day 30. So if you haven't watched our previous video, that is day 30, I'll highly recommend you to watch that previous video and then come back to the video for today, that is architecture of Kubernetes. The reason why I'm telling you is if you don't understand what a Docker platform or what a container platform offers and what is the reason why we need to evolve to a container orchestration platform, you will never understand the reason for container architecture or Kubernetes architecture. So on a very high level, what I told you is your Kubernetes offers four fundamental advantages over Docker. That is, Kubernetes is by default a cluster in nature or cluster in behavior. Then Kubernetes offers something called as auto healing. Kubernetes offers something called as auto scaling. And finally, it offers multiple enterprise level support. Like Kubernetes offers you advanced load balancing, Kubernetes offers you security related things, it offers you advanced networking. So it offers you multiple enterprise level support, which is a major difference between Docker and Kubernetes. So we understood these four things in detail, and today I'm going to explain you the architecture of Kubernetes also using these four examples. So you might ask me that, Abhishek, there are hundreds of videos on internet which explains about the Kubernetes architecture, right? So everybody says that Kubernetes has something called as a control plane, and Kubernetes has something called as data plane, right? So this is something that everybody explains. And probably if you have watched the previous videos, or if you have watched any other video, or if you have even read the documentation of Kubernetes, you know that there are multiple components in control plane. Like Kubernetes has API server, Kubernetes has a component that is called as etcd, Kubernetes has a component that is called as a scheduler, then you have controller manager, and then you have a cloud controller manager which is called as CCM. And similarly in data plane also you have multiple components, like you have your kubelet, you have your kube proxy, you have your container runtime. But what exactly all of these things are? So even I can explain you that these are the different components in control plane, these are the different components in data plane, and each component does these things. But you will never understand the architecture of Kubernetes in this way. So that's why what I'm going to do is I'm going to compare this thing against Docker. So let us try to understand two basic things. In Docker, the simplest thing is container, whereas in Kubernetes, the simplest thing is pod. So I will try to compare both of these things, and how a container is, what happens when a container is created in Docker, and what happens when a pod is created in Kubernetes, so that you will directly understand the architecture of Kubernetes. So you yourself will say what is the advantage of each and every component in Kubernetes and why Kubernetes requires these many components. Whereas in Docker you have 2 to 3 components, but in Kubernetes you have all of these components. By the end of this video, you will understand the advantage of each and every component and why they are actually required. Okay, so watch this video till the end so that you get a clear understanding of these components in Kubernetes architecture, and you will say that Kubernetes is very easy. Though that is our primary goal, to make Kubernetes easy. Okay, so let's start with creation of a container in Docker. So let's say you have this platform. Okay, so this is a virtual machine on top of which you install Docker, let's say. And what you have done as a user is you have created, you have written a Docker file, built images. I'm not going there, but you have run a container using a basic command in Docker, that is Docker run. Okay, so you said Docker run, and then you ran a container, but what is happening under the hood? So if you run a container, nothing will happen, right? Let's say you have installed a application. Let's say you have installed a Java application, and on the platform you don't have Java runtime. Will your Java application actually run? No, it will not run. Similarly, even when you are running a container, you need to have something called as a container runtime. Okay, so without container runtime, your container will never run. So in Docker, you have a container runtime component that is called as Docker shim. So this is something that is happening under the hood in Docker. Okay, so now if we move to Kubernetes, so Kubernetes also need to do some similar behavior, but because Kubernetes is an advanced concept, or because Kubernetes provides you enterprise support with auto healing, auto scaling, and cluster like behavior, what you basically do with Kubernetes is you create a master and you create a worker. Okay, so for a basic example, I am just using one master and one node component or worker component architecture so that it will be very easy for you guys to understand. But in general, there will not be one worker, there will be multiple workers in Kubernetes. It doesn't mean that you cannot create Kubernetes with one single node. You can also do it, but in production, always you have multiple masters and multiple workers. But for easy understanding, let's say you have just one master and you have just one worker. So what happens is in Kubernetes, you will not directly send the request to worker, but your request goes through master. Okay, so your request always goes through something called as a control plane. Now, why you need to do this, I'll explain you, or you will even understand by it yourself. So when you deploy your pod in Kubernetes, the smallest level of deployment is pod. Whereas in Docker, you deploy a container. You can slightly understand both of them or more or less similar kind of things because I'll explain the difference in detail in tomorrow's class. But for now, just understand that container pod is just like a wrapper over your container, which has some advanced capabilities. So when user tries to deploy a pod similar to container or similar to Docker, your pod gets deployed. Okay, let's say your pod is getting deployed on this specific worker node, but you have a component in Kubernetes that is called as kubelet. So what is this kubelet doing is basically this kubelet is responsible for running your pod. Okay, in Docker, basically you have a Docker engine. Okay, and basically you have Docker shim. Okay, in Kubernetes, you have something called as a kubelet, which is responsible for maintaining this Kubernetes pod. Okay, it always looks for, okay, if the pod is running or not. If the pod is not running, because Kubernetes has a feature called auto healing, I have to inform Kubernetes that, okay, the pod is not running, do something. So that's why Kubernetes has a component called kubelet. But even if the pod has to run, like I explained you here, there need to be something called as a container runtime, right? Inside a pod, you will definitely have container. So for this container to run, even on Kubernetes, you need to have something called as a container runtime. But the only difference is in Kubernetes, Docker is not mandatory. In Docker, like I told you, there is something called as Docker shim. But in Kubernetes, you can either use Docker shim, you can either use container D, you can use Creo. What are all these things? These are all competition to Docker shim. Okay, so Docker has only one support, that is Docker shim. Whereas Kubernetes can support containerd, Kubernetes can support Creo, Kubernetes can support Docker shim or any other container runtimes which implements Kubernetes container interface. Now let's not go into the details of it, but understand that Kubernetes has a standard called container interface. If some container runtime, it can be Creo, it can be containerd, it can be Docker shim, if they can implement this container interface or it can implement the standard that Kubernetes has set, then Kubernetes allows you to use that Kubernetes container runtime or that specific container runtime. So what are the two different components that we learned? We have kubelet in Kubernetes, we have container runtime in Kubernetes. Kubelet is basically responsible for ensuring that the pod is always running. If the pod is not running, then Kubernetes will inform. There is a component in Kubernetes. I'll keep that component as suspense, but kubelet will inform this specific component that okay, something has gone with the something has gone wrong with the pod. Let us restart it or let us do something with it. So that is the responsibility of kubelet. And container runtime you already understood. Now in the previous class, in one of the previous classes, I told you that in Docker there is something called as Docker 0, or you have a default networking in Docker that is called as a bridge networking. So this networking is mandatory for running your pod. Even here in Kubernetes, you have something called as kubeproxy. So this kubeproxy basically provides you networking. Like every pod that you are creating, every container that you are creating, it has to be allocated with an IP address, right? And it has to be provided with load balancing capabilities. Because I told you Kubernetes has something called as auto scaling. When you scale your pod, instead of one replica, if you have two replicas to your pod, then there has to be a component which says, okay, send 50% request here, send 50% request here. So that is taken care by kubeproxy. So we talked about three components. One is kubeproxy, which provides networking, IP addresses, and also the load balancing, default load balancing capabilities in Kubernetes. Then you have kubelet, which is actually responsible for running your application. And if your application is not running, or if your pod is not running, then kubelet informs one of the components in control plane that, okay, something is going wrong. And finally, you have container runtime, which actually runs your container. So these are the three components that are available on the worker node. So see, you directly understood what are the different components that are available in worker node of Kubernetes. So you are already done with data plane of Kubernetes, or you are done with the worker component of Kubernetes. Isn't it easy? All of you understood the components that are in worker node. Tomorrow, if somebody asks you in the interview, what are the components that are present in the worker node of Kubernetes, you can directly tell them that, let me erase all of this stuff. Okay, so you can directly tell them that in Kubernetes worker node, there are three components, and those three components are nothing but your, let's write them. So those three components are nothing but, you have kubeproxy, you have kubelet, and you have something called as container runtime. Okay, and you should be practically able to explain the purpose of each of them as well. So that's the reason why I took Docker as an example, so that you guys understand it. So again, let's repeat it. Kubelet is basically responsible for creation of the pods, and it will basically ensure that the pod is always in the running state. If it is not, then it takes the necessary action using the Kubernetes control plane. And then you have something called as kubeproxy. Kubeproxy is basically responsible for the networking, like generating the IP addresses or load balancing. Basically, it uses IP tables on your Linux machine. Okay, so IP tables is a concept where, okay, let's not go into the details of IP tables, but just understand that kubeproxy uses IP table for networking related configuration. And finally, you have container runtime, which is responsible for running your container. Okay, so worker component is done. Now let us move to control plane, or the master component of it. So this worker node or the data plane is basically responsible for running your application. So using these three components, you have technically everything to run your application, right? So kubelet is deploying, kubeproxy is providing the networking, container runtime is providing the execution environment for your container. Now, why you need actually control plane itself? So you should get this question. The reason for that is, for any enterprise level tools or for any enterprise level components, like I told you, there are some specific standards. Okay, now cluster is one specific standard. Like I told you, Kubernetes has cluster. Now, who will decide that the pod creation, like user has created a pod. Now, who will decide that, okay, should the pod be created on node 1? Should the pod be created on node 2? Or should the pod be created on node 3? So this is one specific instruction, but there can be multiple instructions, and there should be a heart, or there should be a core component in your Kubernetes that has to deal with such kind of instructions. Okay, when multiple users are basically trying to access your Kubernetes cluster, or when multiple people are trying to do some kind of hacking or some kind of things, so there has to be a component in Kubernetes which basically acts as a core component of your Kubernetes and takes all the incoming requests, whether you want to in future you want to implement some identity provider related configuration, SSO, or you want to do some security related stuff. So there has to be a core component which is basically doing everything in Kubernetes, and that core component is called as API server. And this component is present in your master component, or you can also call it as a control plane of your Kubernetes. So what is the purpose of API server? So the API server is a component that basically exposes your Kubernetes. Okay, so this Kubernetes has to be exposed to the external world. All of these things are basically internal to your Kubernetes, the data plane, all the worker nodes. But the heart of the Kubernetes is your Kubernetes API server, which basically takes all the requests from external world. Now, what this, let's say the user is trying to create a pod, he tries to access the API server, and from the API server, Kubernetes API server decides that, okay, node 1 is free. But to schedule the component on node 1, you have a component in Kubernetes that is called as scheduler. Okay, so what is the responsibility of scheduler? So scheduler is basically responsible for scheduling your pods or scheduling your resources on Kubernetes. Okay, so who decides the information? API server. But who acts on the information? That is API, that is the kube scheduler. Okay, so what are the two things that we have learned till now? One is API server. The second thing that we learned is scheduler. So scheduler is basically saying go and schedule this on node 1 or node 2. It is receiving this information from API server. After this, let's say that we are deploying your production level applications on this Kubernetes cluster. There has to be a component inside your Kubernetes that basically acts as a backup service, or that basically acts as a backing store of entire cluster information. Okay, even when we are talking about Jenkins, I told you that backup is very essential. In Kubernetes, there is a component that is called as etcd. So etcd is basically a key value store, and the entire Kubernetes cluster information is stored as objects or key value pairs inside this etcd. Okay, so the other component that we learned is etcd. What happens without etcd? You don't have the cluster related information. Tomorrow, if you want to restore the cluster or you want to do any information, etcd is basic component. And finally, you have two more components that are controller manager, and you have cloud controller manager. Let's put this cloud controller manager aside for a moment. If you understand what is a controller manager, so basically, like I told you, Kubernetes supports auto scaling. So to support auto scaling, Kubernetes has some components like, Kubernetes has to automatically detect this, and it has to do kind of things. So for that, Kubernetes has basically some controllers. Okay. For example, replica set. So replica set is basically is the one that is maintaining state of your Kubernetes pods. So tomorrow, let me say that one pod is not enough, and I will schedule two pods. I'll auto scale one of my pod to two pods. So there has to be a component in Kubernetes that ensures that the two components or two pods are actually running. So that is taken care by replica set. In Kubernetes YAML file, if you say I require two pods, so replica set controller basically ensures that the two pods are always running. Now, there has to be a component in Kubernetes which ensures such controllers are always running. So that component is called as controller manager. If you did not understand about controller manager, don't worry about it. In future classes, when we talk about deployments, when we talk about services, by yourself, you will understand what a controller manager is. But for now, just understand that in Kubernetes, by default, there are multiple controllers like replica sets, and there has to be a program, or there has to be a component which ensures that these controllers are running. That component is called as your controller manager, or that manager which is managing these controllers is called as a controller manager. Finally, you have one component that is called as cloud controller manager. Okay, CCM. Many people get confused with this concept, so that's why I thought I'll take this as a different concept and I'll explain you. Okay, so you all know that Kubernetes can be run on cloud platforms like EKS, or you can also run it on AKS or GKE. So what is happening is you are running your Kubernetes on cloud platforms. So basically, these cloud platforms, let's say you are using Elastic Kubernetes service. So there is a user request, or there is a request to create a load balancer, or there is a request to create storage. So if you directly send this information to Kubernetes, so Kubernetes has to understand the underlying cloud provider. Okay, if Kubernetes has to create a load balancer on AWS, or if Kubernetes has to create a storage service on AKS or on Azure. So Kubernetes has to translate the request from the user onto the API request that your cloud provider understands. Okay, so this mechanism has to be implemented on your cloud control manager. That means to say, let's say tomorrow there is a new cloud that is implemented called as Abhishek. Okay, and you want to run Kubernetes on this platform called as Abhishek. Okay, so you want to run Kubernetes on the platform called Abhishek. Now what Kubernetes tells you is that, okay, I cannot write logic for all of these different cloud providers. I will provide you a component called as cloud control manager. So this cloud controller manager is a open source utility. Okay, so this code is available on GitHub. Tomorrow if Abhishek creates a new cloud provider, what Abhishek can do is he can go to this open source GitHub repository and he can write the logic for his cloud provider inside this cloud controller manager. He can create a pull request to the cloud controller manager saying that, okay, so I have implemented a new cloud and I want to support Kubernetes on my cloud provider. So for that reason, what Abhishek has to do is he has to write a bunch of logic and he has to submit to cloud controller manager. So if you are running Kubernetes on-premise, this component is not at all required, or this component does not have to be created at all on your Kubernetes cluster. So these are the various components of your Kubernetes. So if we have to sum up, or if we have to just put that in one specific slide, basically, you have Kubernetes divided into two parts. One is your control plane and one is your data plane. So if you have two worker nodes, on your two worker nodes, you will have Kubernetes data plane components that are three components. One is your kubelet, second is your kubeproxy, third is your container runtime. So every Kubernetes worker node has these three components. So in some cases, you will not see container runtime in some documentations, but end of the day, container runtime is required. So I consider it as also a component. Okay, so this is worker node 1, but even on worker node 2, you will have these three components. Okay, 1, 2, 3. Every worker node will have these components. And then you have something called as Kubernetes master, which has components like your API server, which is heart of your Kubernetes. Every request is received by this API server. Then you have your scheduler, which schedules the resources, whether it has to go on worker node 1, worker node 2. API server will take the decision and scheduler will schedule on that specific thing. And then you have something called as etcd, which is basically your data store, or a key value store, which stores all the information of your cluster. And then you have controller manager, which is manager for your Kubernetes inbuilt controllers. And finally, you have something called as cloud controller manager. Okay, so these are the different components you have to explain in an interview. If your interviewer is asking, tell them that these are the components on your Kubernetes master, and then these are your components on your Kubernetes workers. So this is the control plane and this is the data plane. So control plane is the one that is controlling the actions, and data planes is the one that is actually executing your actions. Okay, I hope the concept is clear. You understood what are the master or control plane components and what are the worker node components. So if you want to practically try this out, even before practically trying, consider this as an assignment that I'm giving to you. So write a detailed notes. Okay, so watch this video and write a detailed notes, post it on your LinkedIn, so that everybody understands, like when a interviewer is trying to approach you, he understands that, okay, this guy has the architecture knowledge on Kubernetes. So post on LinkedIn saying that, okay, today I understood about Kubernetes architecture. These are the different components in Kubernetes, and this is how Kubernetes basically works. So you can draw a specific diagram, like you can basically use paint or something, and tell them that these are the different components in Kubernetes and how one component works with connects with other component. Take pod creation as an example and put all the details, including the diagram as well as the written part, and put that on your GitHub profile, and share that URL on the LinkedIn so that you can create a GitHub profile and you can also share that information on LinkedIn. So this is the assignment for today, and I hope you understood the concept, you understood each and every component. If you did not understand something, put that in the comment section. I'll definitely reply to your comment saying that, okay, so you did not understand about this thing and this is how this component works. If you like the video, click on the like button. If you have any feedback, share that with me in the comment section, and don't forget to share this video with your friends and colleagues. So this is the video for today, guys. I'll see you in the next video tomorrow where we'll try to understand the Kubernetes pod. Thank you so much for watching the video. Take care, everyone. Bye.